Look at that. Delicious burrito bowl. Fats, carbs, proteins, some fiber, a little bit of spicy flavor, some richness. Ooh, this is delicious. In this video, I'll help you to understand how the things that you eat actually become your physical body. You are what you eat, literally. The proteins in your body came from this tiny black bean right here. The glycogen in your liver and muscle cells ultimately comes from the sugars and starches that you eat in your diet. Fats in your body, including subcutaneous fat, adipose tissue, which is filled with a special fat called triglycerides. Where did those fats come from? Right here, this delicious cheese, and maybe this, I thought I saw some sour cream, but maybe it's in the fat of another form. Myelin, steroids, phospholipids. These are all examples of lipids in your body that we are talking about in this class. And where do they come from? The food that you eat. So you literally are what you eat. So what's the function of the digestive system then? It's really to convert the food that we eat into a usable form that we can safely absorb into our body. We can't do this by just holding the burrito bowl or smearing it on our skin, although we might be able to absorb a very small amount of lipids, certainly not enough to nourish the body. The only part of our body that is permeable enough to absorb these molecules of food are really right here. Some in the stomach, a tiny amount up here in the mouth. Of course, we have sublingual delivery of medication, so we know whether it's through absorption of the mucous membrane here or swallowing the chemical then subsequently. We know that there's a little bit of absorption, but much more so here in the stomach. A lot of water, alcohol is also absorbed into the stomach, which is why it can hit one so quickly if you go to a happy hour on an empty stomach, right? You don't have to wait for it to get down here. Alcohol and water can easily be absorbed in through the stomach. This is the primary organ of nutrient absorption, the small intestine. About 80% of our nutrients are absorbed here. The small intestine is small in diameter, but very long. The large intestine, which is the next one in line, is large in diameter, but pretty short, just sort of one lap around and then out the backside. The small intestine is where most of those nutrients are absorbed, and so the food residues that are leaving the small intestine and flowing into the large intestine are mostly devoid of nutrition. We've stripped out most of the nutrition. There still remain some small amounts of starches, perhaps, that haven't been hydrolyzed. It's mostly fiber, and it's really gross, but it is a huge quantity of microbes here in the distal ileum, and then much more so the distal ileum being the end of the small intestine, and then much more so into the colon. This is like our compost pile. And a healthy large intestine or healthy colon contains billions of microbes. They're supposed to be there. And in most cases, they don't make us sick. As a matter of fact, they keep us from getting sick. So by the time the microbes have chewed on the fiber and really stripped out the rest of the remaining nutrition, we have absorbed a few vitamins and maybe water to dehydrate the residue until it is pushed into this area right here, the rectum, sort of a storage area for little turdlets to accumulate into one large piece of feces, which we call a stool or a turd. Then, when we push it out, it passes out through the anus and into the toilet. So there's the long journey. Food goes in one end, waste goes out the other end, and in between, we have to chemically and physically break down the food And then using enzymes and acid and chemicals in bile and chemicals in the pancreas, we chemically liquefy and hydrolyze all of the bonds so that we break that thing down into a usable form, which is then absorbed in the small intestine. And then about from this point on, we're pretty much talking about dehydration and compaction of the waste, and then those healthy microbes stripping out the last bits of nutrition. So there's sort of a quick overview of what we're going to be learning. In this chapter, we're going to be focusing on a couple of key features: the structure, both at a macroscopic level and then a microscopic level. For example, the stomach. We got to see what the lining of the stomach is made of, and what the muscle layers look like, and how it's all held together. And then, of course, we learn about the physiology, what kinds of neurological and endocrinological factors control the stomach, for example. Then in the next chapter, we'll be taking those little nutrients that have been absorbed, things like glucose, fatty acids, and amino acids, and then we'll follow them into the body. Where do they go? What do they become? How does blood sugar become fat in my double chin here? And how is that related to my addiction to carbohydrates? We're going to find out a lot of interesting things as we move along. Here's some of the basic vocabulary we need to be able to talk about. Ingestion. That pretty much means taking a bite, right? You choose to take a bite of the apple, or you choose to put some pasta in your mouth. That's ingestion. Drinking, eating, the selective intake of food. Mastication is the fancy way of saying chewing. So if we want to get our enzymes and acid down into those chemicals, we have to physically smash and mush and grind to increase the surface area. So I can't just swallow a chicken nugget. That's not going to end well. Not only might I choke, but it'll probably give me indigestion because it's going to sit there like a little brick. If I chew it and wash it down with some liquid, now I have a huge surface area of mushed up chicken, and that will be digested much more quickly. So this is an example of what we would call mechanical digestion. Mechanically smushing, grinding, and chewing so that we can increase the surface area, at which point chemical digestion comes into play using acid, enzymes, and bile. From one end of the body to the other, we have to be able to move things along. So propulsion, moving that semi-solid, smushed up stuff from one end to the other. And these are the different forms of propulsion. Deglutition is swallowing. Oftentimes in charting, you're going to see dysphagia as related to this concept here. I mean, a patient who has a difficult time swallowing, they're choking on their food, or after they swallow, they have a really nasty, wet sounding cough. Dysphagia, phage as in macrophage, means to swallow, and dys means abnormal or difficult time. Dysphagia is a deglutition disorder. Peristalsis, this is the wave-like contractions that we see right here, moving that bolus of food. I disagree with their color selection here. This doesn't necessarily have to be brown in color depending on where we are in the digestive tract. If I just had some chips and salsa, that's sort of what it would look like. And as this constricture just behind that liquid or semi-solid moves along with sequential contractions, you see it just sort of gets squirted along. It's a bit like if you try to hold on to a watermelon seed and squeeze your fingers together, it shoots out the other end. It's that sort of movement, but in a long tube. Peristalsis. One feels the urge to have a bowel movement when there are mass movements in the large intestine. So you can really sort of feel a fullness, a shifting. There are sometimes sounds associated with these mass movements. And again, that's to try to get that those little turdlets down into the rectum where more dehydration and compaction can take place. And obviously, depending on a whole bunch of different factors, what you've eaten, how much you've eaten, if you're dehydrated, if you have been otherwise sick, if you have a healthy microbial environment, you have a good gut flora, or if you're really just a meat and potatoes kind of a person. Obviously, the quality of one's stool can vary greatly, and so these mass movements come in all kinds of frequencies. It's totally normal for some people to have 5 or 6 big mass movements a day, resulting in a couple of bowel movements. Other people might only have a few mass movements over the course of a couple of days, and maybe only have the urge to defecate a couple times a week. It is really a broad spectrum of potential outcomes. How about that? Next, there are these segmental contractions. So smooth muscle can sort of slosh the material back and forth without really moving it down the line in a significant way. So segmental contractions help to slosh it around, to stir up the material with the enzymes. The peristalsis moves it down the line and can help to form it back into a bolus. Wow, this chapter is disgusting, isn't it? Super interesting, though. Different forms of secretions along the way are key to chemical digestion. First and foremost, there has to be mucus. From the time we put something in our mouth all the way down to the other end, all along there are goblet cells. Goblet cells are integrated within the epithelium, the lining of the gut, and goblet cells produce mucus. Mucus helps to lubricate and liquefy the digested food or the partially chewed up food. And if you've ever been really dehydrated or chewed on something that's sort of solid, like eating a big pretzel without anything to drink, it sort of absorbs the mucus and it can make it very difficult for you to swallow that material. So that's just one example of how important mucus is. On the other end, of course, dehydration and abnormal gut flora can lead to an underproduction of mucus, which is related to chronic constipation, or an overproduction of mucus, which we see in conditions like ulcerative colitis and Crohn's disease, sometimes irritable bowel syndrome as well. Obviously, there has to be a lot of water mixed in with this mucus. So within our saliva, for example, we have watery saliva and slippery saliva, and they introduce enzymes. So even before you swallow a potato chip, for example, you're already beginning to chemically digest it, thanks to those secretions. Bile works like soap, breaking fats apart into tiny little droplets. That's emulsification. And if you've ever had oil and vinegar salad dressing, then you know what emulsification is. If you leave it on the table, it separates and the oil rises to the top. But if you shake it up, there are herbs and elements within the salad dressing that allow that oil to be shattered and to be suspended as many thousands of tiny droplets. That's what emulsification is, and that's what bile does for your digestive system. Think of it this way. You can't wash dishes without soap. If you have a sink full of greasy dishes and no soap, even with hot water, it's very difficult to get that fat off. In the same way, you cannot digest fats without bile. It will break up those fats like soap, emulsifying them into many tiny droplets, and then the enzymes can come in and chemically digest. Digestion, absorption, and elimination, that rounds out the overview of the digestive system.